All right, good people, I greet you all. So, in the name of God, so let us look at planting and structural drawing into the recently examination, which was written on the 5 December 2023. This is the previous question paper. So, I want us to look at question 5. So, I think we haven't done this one. We'll do them all actually, you understand. So for vandaag, I want us to look at this one. So question 5, which was paying how much? 25 marks. So if you read the question there, it says figure 5 below shows an oblique connection between a cylindrical pipe and a right cone that is placed around the common central sphere to a scale 1:1. Okay, so the very first thing that we are going to do, let us draw this cylindrical, this cone, because this was a what? Was a full cone, isn't it? So they are saying using a scale of 1:1. So I am going to say diameter 75. So you must have your calculator by your side, divide by 2. Simplified further is saying 75 divided by 2. We are getting 37.5. 37.5. So now I take my drawing compass. 37, 35, 36, 37 is between 37 and 38. So it's somewhere there. So now I come and what? And have it somewhere there. This is the diameter 75 that they are talking about. You understand? Then from there I can draw a vertical center line out of dimension. A center line is always out of dimension, isn't it? So where was I placing my compass? Right there. So now I can have the horizontal center line. So now from here going down, I'm going to record 20 diameter. That is my 20 diameter. 20 millimeter. 20 diameter. So I get this one, faint. Then from there I go down just a little bit. I stop there. I stop here. So now I can construct this one from here till the solid, which is this one. From here till there, I can say it solid in. There you go. Then after that, let's see. We are given a dimension from here till there, which is 34. Come 35. There is a 34, isn't it? So what do you do with that 34? There in 34, you are going to draw a faint diameter. This one, faint diameter of 40. So 40 divided by 2, how much are you getting? 20. So you open your compass to 20 millimeter. I am trying to be fast. So this is it. So there by your 35 end, I can now draw a faint. Draw it faint. You understand? So now I cannot draw a horizontal center line as usual. You understand? Because this is they said it's a sphere. So it's because they said they are sharing the same common central sphere. So from there, if you take a closer look, sorry if I'm rushing you, if you take a closer look, a dimension from there till to your apex point somewhere there, we are not given. You understand? So that is why we had to get this one, so that now you join this point with your with the draw it faint. Now you are going to draw a line. In mathematics they call it a tangent. So it's a line that touches the circumference of the cycle. You understand? So it's not crossing, it mustn't cross, it mustn't right next to or something like this. You see, it's supposed to just touch You understand? Then from there, so even this side, this is what you do. There you go. You understand? So after we've done that, what are we going to do? Bring back your question. You can see that you are told that this cylindrical pipe is joining this conical pipe at an angle of what? Of 45. Take your set square, your 45-degree set square, which is this one, and then your t-square against your drawing board or drawing table. Then from that point, you are going to draw a faint a center line. Actually, center line. Remember, a center line, you can even draw it solid. I prefer it to draw it solid right from in time. You understand? So let me position it very well. Then from there, what are you expected to do? So we are given a dimension. They said from that point till here is what? Is 38 millimeter. There is 40, 39, 38 is right there. So now I mark where at 0 there. Okay, so now I must get a line that is perpendicular against the what? This center line. So a perpendicular line, what do we have there in a perpendicular? What degrees do we have? We are having 90 degrees. So which means if I draw this line using 45, which means 45, 90 minus 45 is 45, which means I must still use the what? The very same what? Set square. So you just flash it like this, then there you go. Why? Because why am I seems to be emphasizing on that point? Because I've seen students they tend to fumble there. You understand? So from there, I am going to project this. So now from here till there, solid. You see this line is supposed to be parallel to this one. Supposed to be parallel to your center. So now I just projected it like this up until it touched that cycle of ours. Then I go dark. And now why do I draw it dark? Because now I know Oguti from here till there is dark. So this is good as if it was further extended till like this. You understand? So what I did to this side, also flash it back. There you go. Solid. So now I can come back and what? And have it dark like this. So right now I can have my given view complete. Solid here, solid right there. Okay, so now what do I have to do? I have to get the line of penetration. So what am I going to get the line? How am I going to get it? So I have to what? Get the auxiliary of what? Of this conical cylindrical pipe, this one, which is the same as this one. Open it to 4, isn't it? Somewhere down there. So you are not restricted to how long is it supposed to your auxiliary, how long is it supposed to be away from your given view. You understand? As long as it's above not less than 20 millimeter. So which means you cannot draw this one very close like this. You rather make it 20 millimeter, then from there you understand. So if it's any dimension above 20 millimeter, you are not going to be penalized. But if it's less than, you understand. So this, it will connect with that one. It's already there, isn't it? It's one in the same dimension. There you go. You understand? So now what are we going to do? We are going to divide the circle. We are going to divide the auxiliary of your conical pipe in what? In 12 equal space. And before that, I like it to do like this, to show Uguti this was what? A full cone like this. show it what it was a full cone by getting what these hidden details like that. So now divide your circle into 12 equal parts. You've got two methods of dividing the circle into 12 equal parts. You also remember using a set square or using your drawing compass. So there you go. This angle of 30 degrees clockwise direction, angle 60 anti-clockwise. Then from there, twist it like this, angle 60 clockwise. Then from there, 30 anti-clockwise. Then from there, I'll decide to what to make my zero here. I'll count clockwise 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. Eh? Okay, so now when I come to the auxiliary of the cylindrical pipe, so I have to divide it into 12 equal parts. So in this one, I am going to use what? A divider. Eh? So I place my compass at this point, further extend it to the center, then I strike an arc here, and I strike an arc there. Then I come to this one, I strike an arc there, and I strike an arc here. I come to this one, I strike an arc here, I strike an arc here. I come to the very last one. But do you see what is happening there? I must get the exact point, because I don't want to assume. So there it is. So I place my compass here to the center, isn't it? Now I strike my arc here and strike my arc there. You understand? So now if the zero of the auxiliary of your conical pipe is this one, so it must intersect with the auxiliary of the cylindrical pipe. You understand? So the numbering system that you are using up there of the conical, it's supposed to intersect with what? With the numbering system of what? Of your cylindrical pipe. So let's number. If this is my 0, eh? There it goes, there it goes, there it goes. Once it touch the small pipe that is being joined to this conical, so it's gonna go like this. So which means, in other ways, your 0 of your conical, of your cylindrical pipe is going to be right there. You understand? And this one, it will go anti-clockwise. So if I've got a 0 there, which means my 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, back to 0. You understand? So, and we know Uguti, join them from here till there. 5 with 11, 1 with 7. All these lines, they must pass your center point. You understand? So you mustn't get a line that is going to be like this. Maybe you want to join 3 and 10. You see, it's out of order. It's out of order. All of them, they must pass your center point. So 10 with 4, 3 with 9 already there, then 2 with 8. Like this we go. Remember, we are doing this, we want to get the line of penetration this side. Okay, so now you are going to project these points vertically down from your auxiliary of your conical down. Once they touch this line of yours, they must be directed to your apex point there. So vertically down using your t-square or your set square against your t square. So there it goes. Line 1 is in together with with 11, 2 with 10, there it goes. Then 4 together with 8, 5 together with 7. Once they touch there, you're supposed to direct them to your to your apex point. There they go. Apex point. There you go. Like this we go. Faint, eh? Like this we go. Okay, So now what you did here, you're supposed to do it were even on this auxiliary of your cylindrical pipe. So these lines, they'll be parallel as well, so which means you are going to draw them using 45 degrees, touching it, running along your what, your t-square. What is your t-square? Is attached to your what, to your drawing table or your drawing board. So there you go, 1 with 11 faint. So do you see that the line, the point of 1 and 11 and 1 and 11, so where they collide, they give you a point. So trace it, this is it. Let me position this. So this is 1 and 11, there it goes, and 1 and 11, that goes from there to your apex point. So they are giving us a point right there. Then the 0, there it is, the 0 of your conical. So I've got a point right there. You understand? So let's get point 2. 2 is in line with what? With point 10 most. So you take it, angle of the 45, there it goes, must intersect with what? With the line of 2 and 10 of your conical. There it goes. So which means where they're colliding, they're meeting, is your point. You understand? So we get the what, the line of penetration by plotting colliding points. You understand? So those points, they must be plotted, they must be visible, so that a marker or an examiner will see how did you got them. You understand? So now we have 3 and 9. Again, 3 and 9, there they are colliding. So that is why I like it to draw a center line, so that I know that I've got 3 lines before the center line and 3 lines after the center line. So now point 8 and 4, again they'll be in the same line. There they go. There it is, from there to your apex point, which means where they are meeting, I've got a point right there. Are we together? And then point 5 and 7, there they go. So 5 and 7, there it goes, from here to your apex point. There it is. Then point 6 of your cylindrical pipe, together with the 6, which is the last one, there it is. We started at 0, we end at 6. So that's how you get this line of penetration. So from there, you can now join your lines using your flex curve or freehand knit. There you go, like this you go. Hey man. So that's how you get the line of your penetration. Okay, so go back to your question. You'll learn Uguti, or you'll notice Uguti, we are given the what? The cutting plane. The cutting plane. So this x, they are saying, please note that x is it's a joint. That's where they are cutting it. You understand? So from there, what are you expected to do? So if it's given like this, which means they want all the what, the development of the conical and the of the cylindrical. You understand? So from there, take your drawing compass. It's up to you which one you are going to start with. Let's start with the what? With the cone. So I am going to use the what, the apex point. Place your compass at your apex point, further extend it to this point like this, then get a faint line that's gonna behave like this, a faint line like this. Then now let me put it like this. Let me see. By look of things, I am not going to, because you must plan your space of your development, whether is it going to fit this side or this side. You understand? So because it is not necessary for the construction of your development to be attached to a very same apex point. You can take this development to any space of your choice where you are comfortable and you can see ukuthi is going to fit it there. You understand? So mina, let me look at it that I am going to have it complete here. If not, I will have to shift it aside, because it can look this side, it can look upside down, it can look straight up. It's still one and the same thing as long as it's accurate and correct. So you remember what we've got, L is equals to pi diameter over 12. So we use this one to get the true length. So now when you substitute pi, d is going to be, when you substitute d is going to be, remember the scale is 1:1, isn't it? It's going to be 75 over 12. So L is going to be the true length now of your development, and you mark it up until to 12. Or graphically, you just place your compass where at this point, and remember that these points are equal to each other, isn't it? So any of your choice. So this is it. So now I come and say I must get 6 this side and 6 this side. 5, 4, 3. So it shows what is going to my auxiliary. So which means I can shift it this side. So I can now say this right there. There we go. 7 to your apex point. 8, 9, 10, 11, 0. Okay, so from there, what are we going to do? So now we are going to place your compass to this point. And before we even do that, so you are going to have this point. Okay, let's firstly get point 0. Place your compass at your point 0, thereby apex point. There you go. Then you're gonna get an arc that's gonna be like this. There you go. And like this you go. Faint, eh? So remember that we were told which there is x here, x here, x there. So please note the x is the joint. So from there, what are you expected to do? So bring your textbook. So the step that you are about to do now is this one. If you go there by page 34, this step that we are about to do here now, taking this point, this point of your line of penetration is which one? Is this step. You understand? This was the given view. This was the middle step. This was the final step. You understand? So this step is what you have to do here. You understand? How? Now this is 0, isn't it? Now the line of 11 and 1, you further extend it just a little bit. There it goes. There it goes. Is the point there? You understand? Then now you place your compass at your apex, further extend it to that point. So do it like this. So you must try to be accurate. So you know me now, I'm using a small drawing compass. Sometimes it disadvantages me, sometimes it's an advantage to me, especially on engineering drawing. So this is a line of 1 and 11. This is the line of what? This is the line of 0 and 6 actually. So now let's go to the line of 2 and 10, isn't it? So you take this point, further extend it horizontally. So there you go. This seems to be in the same line. This seems to be in the same line. Place it there, just a little bit up. Then from there you go. There you go. This is the line of 2 and 10. So now the line of 3 and 9, which is the center. There it goes. You understand? Horizontally. From there, you place your compass at your apex point. And then further extend it to that line. I am going to draw it as center line, so that I do not confuse myself. There it is. Like this we go. You understand? Okay, so I must have 3 more after the center line, which is the line of 4 and 8. There it goes. Is this one, isn't it? 4 and 8. Now go there, take it there. From here, once it touch there, place your compass at apex point, further extend to this line that you just got. Then now you go like this you go, and then from there the line of 5 and 7, which is there, is that one. You do the same thing. There you go. Horizontal straight line. Once it touch it there, so you project it to your development. There you go. So the line of 6 in line with 0, which is the last one, you see that one. There it goes. Once it gets there, there you go. So like this we go. There you go. Okay, remember that this is the development of what, of the cone, you understand? So this one. So now why am I saying that? So that you take note where is the cutting, you understand? So from there till there is the what, is the cutting plane. So this point is this one. There it is, and have a point there. So and from here till there, which is this line, the last one, the last one, which is that one. So now your 30mm ruler, without fear or favor, we know from here till there it's going to be solid. So again from here at the end, from here till there, solid again. So which is your x. So it's now coming. So the upper point, which is this one, which is 0.6, that one, which is, trace it, there it goes, isn't it? From here goes there, from there it goes there, which means is the first one, isn't it? So it's gonna collide with what? With 0.6. You understand? So with 0.6 up there. So from, let me position the camera. So there it is. Let me repeat that. This is 6. There it goes from there, isn't it? From here, there it goes, is the first line. So it's gonna intersect with what? With 6. Then 5. That goes, it must meet with 0.5. So this is the line of 5. That goes from here, which means it's the second line. So you understand? So that's how we get these points. You must understand. Don't claim and be like, hey, they go diagonal. So you must know how are they coming. You understand? So for there it is. Want to touch the cutting plane, goes from here, isn't it? This is the arc of 4 is going to intersect with the line of 4. So that is why indeed this one is having a point there. So now point 3, the center, want to touch the line of your penetration, so it's gonna go center. This is it. So indeed I've got a point right there. So I will plant this point visible. So point 2, that goes, isn't it, at your apex point, but once it touches the line of penetration, 2, there it is, intersecting with what, with 2 right there, too close. And then point 1 with 11, once it touches your cutting plane, the line of your penetration, intersect with your what, with your point 1 this side. Understand? That goes, which means it's right there. So your x, which is your 0, which is the last one, with your x right there. You understand? Are we together? Now we know Uguti 7 is in line with what? With 5, which means I am going to have a point there. And 8 is in line with 4. That goes, I am going to have a point right here. Then 9 with 3, which is the center. 10 with 2, there it is, very close to 1. 11 and back to 0. So then you take your flex curve. There you go. Simple, eh? There you go. Like this you go. Are we together? Then now from here till there you can have it now solid without fear or favor. So assuming it was check this, assuming it was maybe cut it like this, we're going to have something of this nature here. Understand? And again, assuming the cutting plane of your cone, it was maybe put it from here till there. This development was not going to be like this again. You understand? So from there you can now come back and have this one solid. This one, let me put it like this. You can now draw it solid, further extend it till there, have it. There you go. From 0 to 0. Somebody will say it's from 0 to hero. Yes, that's how you get your what, your development. So like as I've said before, that this development, somebody can put it aside, is still one and the same thing. Somebody can put it this portion and still draw it upside down or straight up, is still one and the same thing. You understand? As long as you took these true lengths collect, you understand. So let's look at the development of the cylindrical, because once we have the line of penetration, we can be able to get even the development of this one. Hence they even told you, even do you read the question, so the given view, you'd be given 2 marks. The line of penetration, 4 marks. The development of the pattern of the right cone, 8 marks. The development of the pattern of the cylindrical pipe, which is what we have to get now. You understand? So how are we going to get that? So since you have put it this development of your cone this side, so you'll be obliged to put the development of your cylindrical pipe this other side. I'm trying to be fast actually, you understand? So take your eraser. So erase this one from here till there. Let me erase it. So now check how are you going to get the development of your cylindrical pipe. So now I'll just further extend this line just a little bit out of dimension. This one, there you go. You understand? So now I'll want to start my development here, so that I don't interfere with with this part of my front view. You understand? So I'll say this is my point 0. So from there, graphically, I come and record. Remember now that the space of the length of the development, you are not going to use the space of your auxiliary of your cone. So which means again, you are going to say L is equals to pi diameter over 12. Then you come and say L pi, this is not x, pi. So now when you substitute D now, you are going to use the radius of this one. the radius of this one, which is 40, 40 divided by 12, how much are you getting? So that answer that you get is the one that you are going to use your compass and open. Let's say it's 5 millimeter. You open your compass to 5 millimeter and mark 5, 5, 5, 5, 5, 5, 5, 5 up until these 5 of yours, they are 10. You understand? Or graphically, you can come back here and what? And have this one, because these are equally spaced, most. But please, in the final examination, please quote these small formulas, especially day by entry. It is absolutely necessary because we develop using calculations. You understand? They will even say compulsory. So now this is my 0. I will come and say 1, 2. You understand? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. Are we there? So which means we must further extend that line just a little bit. There it is. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. So what do I do now? So you are going to project them at an angle of 45 like this, out of dimension, just a little bit up. You understand? There you go. Faint, faint, faint. There you go. Like this we go. There you go. Like this we go. Like this we go. Like that you go. Okay, so now from 0, 1, 2, 3, blah, 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 11, 10, 11, back to 0. Without fear or favor, we are going to have this line dark. Why? Because of from here till there is solid. So without fear or favor, we know what this one supposed to be solid. You understand? This one supposed to be solid. Then from there, we are going to project these points like this. This is the line, point 0, faint. There it goes, faint, faint, faint. This is the center. I draw it as a center. There you go. There you go. There you go. There you go. So the second one, then the other one, too close to each other. They seems to be in the same line, point 4, 5, and 6. They seems to be in the same line. Okay, actually they don't have to be. They don't have to be, because it is not supposed to be a straight line as far as I'm concerned. You understand? So which means even somewhere there 4, 5, 6, 7, 8, they'll be in the what? In the same line. You understand? But I'm not convinced they are not supposed to be in the same line. Okay, so now let's get this. So now this is 0. Oh, now we're tracing here, not there, isn't it? This is 0. We are tracing using the auxiliary of your cylindrical pipe. This one, not that one, this one. So there is 0. And remember that you've got an X here, you've got an X there, again there, and again there. That must give you a hint. Without fear or favor, here is supposed to be dark from here till there, which means even here till right there is going to be solid or dark. You understand? So even at the end, do the same thing. There you go. You understand? So now this is 0. go, must intersect with a 0. So I've got a point there. Then 1, there it goes from here, must intersect with what? 1. There it goes. Hey, bon. So that's how we get to this point. 2, there it goes. Want to touch the line of your penetration, goes intersect with what? With the point 2. Hey, bon. 3, which is the center, that goes must give me a point intersect with what? With 3. 3, that goes center, eh? That goes. Then 4, that goes intersect with what? With 4. So 5, that goes. So I'm not quite sure whether is it supposed to come down just a little bit or up, because that's why actually it is important. Let me see. This is 3, eh? 3, they are actually in the same line, which I'm not convinced. The 0.6 must be a highest point, or it must come a little bit low, so that maybe at the, because the shape is either we get something of this nature, which means maybe your 0.6 is somewhere there, or we get something of this nature. If I may rough sketch, goes and maybe your 0.6 is somewhere there, you understand? So between the two. So in this case, it mustn't be just a straight line, and be a straight line like this. No, it's like that you can say your 0.6 is somewhere there. No, I am not absolutely convinced about that. But what is important, follow the protocol, so that in case you lose marks, you know the marks that you are going to lose are only this part. But your 0 is your starting and ending is absolutely correct, you understand? Because 4 is right there. You understand? So by look of things, according to me, there seems to be in the same line, which I am not convinced with that. So now you can have this solid, like as I've said, they must be in this format. This I am not convinced with it. There must be such that your 6 is up there, or is a little bit down there, you understand? So not as a straight line like this. You understand? So that's how you get the development of this. So remember the question, they didn't say complete the top view of the cone. So if they said complete the top view of the cone, we are going to project this line, but in the final examination, do not further complete the top view, because you are not asked to do so. You are not asked to do so. So let's say they said complete it. So that's how you are going to, let me just cover it up, you understand? So this is 0.0. Once it touch there, after you've gotten your line of penetration, you are going to go just a little bit below, so that you get a point there. This is 0 and 0 must intersect with a 0, isn't it? So 0.1, there you go. 0.1 is in line with 7. Remember, we did this. I'm just doing this for interested point purpose. So there is a line of 1 and line of 11. We are not asked to do so, There you go. This is 2 and 10. 3, they're already there. And then from here, this is 4 and 8. So which means I've got a point there, and I've got a point here. Then now 5 and 7. There they go. I've got a point somewhere there. And I've got a point here. And the last one, which is 0.6, I've got a point right there. So you can then figure out 9 is here and 3 is somewhere there. Then you join them using your free hand. Using your free hand or your flex curve. Remember that we are not asked to do so. I'm just doing it for the sake of for the sake of better understanding, in case in some such kind of scenarios where they are saying expose the top view now, understand, which means again then you will come back here and have this one a dark, this one dark, then you understand. Okay, thank you very much, guys. That was Mr. Nkosi. That was Mr. Nkosi for you. See you on the next video. Don't forget to subscribe and like the channel. That was planting and structural steel drawing, and to the previous question papers, X papers, which means it was written in the morning. All the morning papers are X papers, isn't it? So under the question 5, this one. Okay, thank you very much, guys. See you on the next video. Don't I almost say don't subscribe. Don't forget to subscribe and like, and give it a thumbs up, guys, and comment. Bye, donkey.